All right, so for problems 11.4 through 11.6, we have this setting. A random sample of traffic tickets given to motorists in a large city is examined, and the tickets are classified according to the race of the driver. The results are summarized in this table here. So here, the race is broken up into white, black, Hispanic, and other people. The proportion of the city's population in each of the racial categories listed above is as follows. So the portion of white is 0.55, black 0.3, Hispanic 0.08, and other 0.07. And then we have the first question going to be that we want to test the null hypothesis HO. We want to test HO. The racial distribution of traffic tickets in the city is the same as the racial distribution of the city's population. So we want to basically, so our null hypothesis is that the proportions of white people, black people, Hispanic, and other among the population is the same in this group and this group. So the proportion of each race that get given traffic tickets is the same as it is in the population of just people. Okay, so if we assume that the null hypothesis is true, the expected number of Hispanic drivers who would receive a ticket is, okay, so the key is to figure out first the overall idea is to figure out what proportion of this entire group are white people, what proportion are black, what proportion are Hispanic, and what proportion are other. So let's make another column here just for the total. So if we add all those up, we'll get 148. So to figure out, these are the observed, like these are the observed values. Observed. And the expected, let's just put it below so I can not have to write so much. The expected would be found by taking the corresponding proportion here. So taking 55% of the total, and for black people, 30% of the total, 8% of the total for Hispanic, and 7% of the total for other. So for Hispanic, I just multiply 148 by 0.08. Now I would expect 11.84 people that are Hispanic to receive a ticket. Let's just go ahead and calculate the other ones, because we're going to need it in the next two problems. So for white people, 0.55 times 148, 81.4. Black people, 0.3 times 148, 44.4, and other 0.07 times 148, 1.36. These are my expected values. Okay, so 5, we compute the value of the chi-square statistic to be 6.58, and assuming that the conditions for inference are met, the p-value of our test is, so remember the chi-square distribution is going to be some, curve-looking thing. It's going to have like a tail to one side. And we only care about the area to the right of the chi-square statistic. So in this distribution, we have a chi-square of 6.58. Our p-value is this proportion to the right of that. This is our p-value. Now you can use your formula packet, but it's a lot better to use your calculator, because it's going to give you more exact value. Now, for that, you can go to distribution, go to press vars, or no, press second and then go to distribution, and go to chi-square CDF. And here, the syntax will be the lower bound, which will be 6.58, comma upper, which is again, it'll be like going to like a million or whatever it's infinity, you can say. So enter like a very large number, followed by degrees of freedom. So let me just, so in here, lower, upper, degrees of freedom. So the degrees of freedom is just one less than number of categories. So there's 4 categories. The degrees of freedom would be 3. So I enter 3. And this will be my p-value. The p-value will be about 0.087. And so then that's going to be between 0.05 and 0.1. So our answer will be C. And for 11.6, the category that contributes the largest components of the chi-square statistic is, okay, so let me actually break this down in detail just so you can understand it in your refresher. Remember, the chi-square statistic is the sum of all the expected values. I'm sorry, the observed values, observed minus expected squared over the expected. So you do that for each group. So that you would basically, it doesn't matter the order, but you would take the observed number of white people minus expected squared and divided by the 81.4. So the formula would start to look like this. Let me zoom out so you can see the whole thing. So it would look like 69 minus 81.4 squared over 81.4 plus for the next one, the observed was 52 minus the expected minus 44.4 squared over 44.4 plus Hispanic observed 18 minus 11.84 squared over 11.84. And the other observed 9 minus 10.36 is expected over 10.36. But you do the math and you want to see which of these will give you the biggest value. Now, I already calculated, so I'm not going to go through it. I'll just show you what you should get, but you should definitely practice making sure you do this in your calculator. So for this first component, you should get about 1.89. Here, you should get about 1.3. This part, you should get about 3.2. And this last part, you get about 1 or 0.18-ish, approximately. Now, I think there's also, I know some of the more newer calculators may have a function to calculate this for these types of chi-square statistics for the goodness of fit test. This is a goodness of fit. This is a chi-square test for goodness of fit. The one I have doesn't, but go in here, it's only going to have. You only have the chi-square test for homogeneity. But that's not too big of a deal. But anyways, so you can see the biggest contributor was the Hispanic group that contributed 3.2. So their answer would then be C. And again, you make sure you always are thinking logically. You're basically looking for which of these values were off by its expected value, relatively speaking. So even though the black values for, or like the black 58, I'm sorry, 52 and the 44 are about 6, 8 off. And 18 and 11.84 is only like 7 off. Proportionally, 7 is a lot bigger of 7 over 18 is a lot bigger than, than 8 over 52. But that's just the logic. You can always calculate the values. In either case, your answer should be C. There you go.